Hello and welcome to episode number 18 of Gowing Life's Longevity Weekly. I'm your host Chris Kerwin, and this is a show where I bring you all the news and updates from the world of health, wellness and longevity. And today we're going to be talking about studying neurological disease with pluripotent stem cells, my chat with the co-founder and CEO of MediMusic, Gary Jones, and also the mind-controlling Parasite. So without further ado, let's get started. So firstly is part one of a series of articles that I'm writing on studying age-related neurological diseases with induced pluripotent stem cells. Neurological disease impacts the central and the peripheral nervous system, impairing things such as mental capacity, motor function, learning, and even language. And it was shown from 1990 to 2016 that global deaths from these conditions increased by over 40%. Recent breakthroughs and technological advancements in genomic sequencing has enabled the genetic screening of patients suffering from neurological disease, leading to an increasingly large library of genetic causes of these disorders being revealed. However, mapping the entire pathogenic pathway is a task that is yet to be fully completed for the majority of these neurological conditions. Disease models are crucial in understanding the underlying cause of these diseases. Studies on transgenic animal models, especially mice, have provided valuable insight into a variety of environmental and genetic conditions that impact neuronal functions and the brain development. The major benefit of using animal models is that they enable the observation of the disease pathway in a living organism. Animal studies, however, have their limitations. Species differences mean that animal models almost always fail to accurately mimic the complex nature of human neurological phenotypes. This is due to the physiological dissimilarities between mice and human central nervous systems. It is obvious that in terms of neuron population and volume, the human cerebral cortex is far larger than that of a mouse, signifying a structure of far greater complexity. One of the major challenges in studying neurological diseases is the inaccessibility of disease tissue, which is why disease models using patient-derived cells have been so rare. The introduction of induced pluripotent stem cell, or iPSC technology in 2006 by Dr. Yamanaka was a revolutionary moment. It demonstrated the ability to artificially induce pluripotent stem cells, which meant that stem cells no longer needed to be sourced from an embryo. So this concluded part one of the series, and be sure to check out part two, which will be coming up this week. And secondly, earlier this week I had the absolute pleasure of being joined by Gary Jones, CEO and co-founder of MediMusic, a company that is leveraging the power of music and artificial intelligence to help promote mental and physical well-being. MediMusic's algorithm, otherwise known as a digital drip, uses biometric data and intuitively compiles a playlist designed to promote positive emotions and alleviate anxiety, stress and pain. So here's a little clip from our chat. So you mentioned a little bit about the benefits there, reducing anxiety, stress, pain. Could you just delve a little bit deeper into those and why certain songs do actually do this?
It's not so much certain songs for us, it's the order in which we actually dispense them that's important. So, the personal preferences in terms of genre are important. Songs that remind you of certain things in your life are important. But what we look to do is create an experience that reduces, as you said, reduces pain. And in doing so, it improves the medication efficiency for both types of drug, both types of morbidity. And if you look at it, there's something like 73 billion spent every year on analgesics with an annual growth of about 3.8% globally. That's a huge amount of money. If music can reduce a percentage of that, then it's a win-win for everybody because you're not polluting your body as such with medication that you don't necessarily need that can be replaced by something that's far more pleasurable.
So thanks again to Gary for a really fascinating chat on what seems to be a really amazing product. So if you want to go and check out the full video, then I'll leave the link in the description below. And finally, Toxoplasma gondii, or T. gondii, is a parasitic pathogen that comes from the protozoan family. While this parasite is capable of infecting any warm-blooded animal, including humans, it can only sexually reproduce when it infects felines. But what makes this parasite remarkable, however, is its ability to change the behaviour of the infected subjects, or in other words, its mind-controlling ability. Studies have found that rodents infected with the parasite exhibit behavioural changes, such as a newfound attraction to cat urine, that make them much more likely to be preyed upon by their feline predators. The mechanism used by the pathogen to achieve this is extremely impressive, and research suggests that the parasite can actually make epigenetic changes to key rodent genes, leading to the rewiring of certain circuits in the brain. This could be an evolutionary adaptation to increase its chances of finding its way back to the feline host in which it can reproduce. So what about its effect in humans? Well, although infection of this parasite is extremely common, as high as up to 30 to 50% of the global population, in humans it is relatively harmless. It occasionally causes mild flu-like symptoms shortly following infection, but then progresses to latent toxoplasmosis, which, though permanent, is asymptomatic and prevents a person from being infected a second time. However, serious and potentially deadly infections can occur in children and the immunocompromised. Toxoplasma gondii causes approximately 750 deaths annually in the United States. But can toxoplasmosis alter human behaviour as it does in rodents? Well, yes. Although the effect is far more mild than in that of a rodent, studies have found associations between T. gondii infection and a number of human behavioural changes, including slower reaction times, more car accidents, a reduced sense of fear and self-preservation, increased aggression, increased suicide rates, and even the increased probability of being schizophrenic. Scary stuff. Now, if you want to go and find out more about this fascinating parasite, please go and check out Alex's article in which he describes a love story for the ages with Ratnus, the late Raticus, and Dr. Floof. Go and check it out. And that is it for another episode of Longevity Weekly. So I really hope you enjoyed it. As always, if you want to find out any more about what I talked about today, then I'll leave the links in the description below. Also, go onto the Gowing Life website to check out the series of articles on the hallmarks of aging that we've got up this week. So yeah, be sure to go check it out. I hope you've enjoyed it, and I'll see you again next week. Thank you very much.